GSLV-F08 mission carrying the 2-ton class GSAT-6A communication satellite will open a new chapter for the Indian Space Research Organisation. With an eye firmly on the all-important Chandrayaan-2, the space agency is trying out a few critical components, which include induction of high-thrust Vikas engine and electromechanical actuation system in place of electrohydraulic actuation in the rocket's second stage. The next-generation Vikas engine developed by the Liquid Propulsion Systems Centre, LPSC, is being flown for the first time. LPSC Director V Narayanan told Express that the improved engine would give a significant advantage in terms of enhancing payload capability. Usually, the chamber pressure is 58 bar, but with the use of high-thrust Vikas engine, we will achieve 62 bar, which is a 6% increase in thrust that gives us 70 kilograms of additional payload gain in this mission. Right now, we are going to use the high-thrust Vikas engine only in the second stage. Basically, we are validating it. For Chandrayaan-2 mission, we will be using 5 such engines aiming for a payload gain of around 250 kilograms, Narayanan said. Another important experiment that the National Space Agency is attempting is last depletion mode shutdown. Generally, scientists store extra propellant in the tank and cut off the upper cryogenic stage after reaching desired velocity. However, this time they are attempting to deplete the liquid oxygen, which means using up another 60 to 70 kilograms of propellant in order to achieve 4-5 seconds of additional burn duration. Narayanan said this would be the best way of mission planning and optimum utilization of propellants. All these new things are being done keeping lunar mission in the mind and ISRO's bigger game plan to increase GSLV payload capability. For Chandrayaan-2, we are formulating a perfect combination. The 4 strap-ons and second stage will be boosted with high-thrust Vikas engines. Cryogenic upper stage will be loaded with enhanced propellants of 15 tons instead of current 12.8 tons and will be operated with 9.5-ton thrust compared to the present 7.5. ISRO Chairman K. Sivan told Express that the high-thrust Vikas engine has been under development for the past 3 years and is robust. It has cleared several tests, he said. It was developed as part of ISRO's plans to have GSLV launches with heavier payloads. GSLV Mk2 and GSLV Mk3, when stabilized, will have huge international demand. On introduction of electromechanical actuation system in place of electrohydraulic actuation in the second stage of the rocket, Sivan said the new system is simpler and more robust, which increases the vehicle's reliability. The GSLV-F08 launch is scheduled from the second launch pad at Satish Dhawan Space Centre, Sriharikota at 4:56 p.m. It is the 12th flight of GSLV and 6th flight with indigenous cryogenic upper stage. The payload GSAT-6A is a high-power S-band communication satellite. It will be India's second predominantly S-band communications satellite, the first being the GSAT-6. It will complement GSAT-6, which has been orbiting Earth since August 2015. The purpose of the satellite is to provide a platform for developing technologies such as demonstration of 6 meters S-band unfurlable antenna, handheld ground terminals and network management techniques. These are useful in satellite-based mobile communication applications. According to Liquid Propulsion Systems Centre Director V Narayanan, the Chandrayaan-2 mission will see use of 5 next-generation Vikas engines. We are aiming for a payload gain of around 250 kilograms, he said. Salient features of satellite. 1. Provides mobile communication for India through multi-beam coverage facility. 2. 6 meters diameter unfurlable antenna for use communication link. 3. 0.8 meters fixed antenna for hub communication link.